Sure.
Okay, good morning, everybody. Once again, I would like to welcome you all to the third day of the workshop. So today we will be learning a very interesting, actually a mechanical device. See, so far we have done, the product that we use in our daily lives, like a mobile stand, which is a simple, product that we use, and then there's a pen stand, which we find a lot of pen stand in the market and all those things. So far we have not done anything which is particularly related to any engineering thing we have not done. So one of the objective of this workshop is also to show that you can actually do some engineering stuff also with this tool. So one of the most fundamental thing that you would like to do is making a nut bolt. Okay, because all the shapes that you are going to design, let us say you are making any product and you are designing an enclosure around it, you definitely have to make arrangement where you can screw things up, and connect them with a screw. And so this was the idea of Champit sir, that there should be something which is a mechanical assembly kind of a thing and all those things, and it's a working screw and nut. So he will actually show you the video also, where he'll show you how to how the screw is getting into the nut and getting tightened and all those things. So and he claims that this is one of the most difficult design that we are going to learn in this training program, because you have to see the threading to come properly both on the screw and both inside the nut. So I'm sure you're going to like it and you'll learn something new, and it will bring out your creativity more to try more intricate shapes, because it is going to be little intricate. Okay, so with this, I would give the control to Chanpit sir. But before he starts with his design of today, which is nut and bolt, we are going to spend some time on 3D printing, because yesterday also we could not do that. We have saved the file, STL file we could save, but after that, taking it to 3D printing, there are some steps involved which are specific to a particular 3D printer. So that we are going to do. So what I suggest is, let us start with that, because 3D printing is on both days we could not do much on 3D printing part. And after that, I will take questions from the previous day if there are any, because now I have shared both the videos with you, day 1 and day 2. If there are any questions, I will take after the 3D printing session, which is I think about 15-20 minutes. And then we can, go to the today's design. This is fine, Chanpit sir, with you? Is it fine?
Yes, sir. Yes, sir.
So we can do 3D printing part first, and then we can go to the query session of yesterday and day before queries, and then we can go to the today's design. Fine?
Yes, sir.
So maybe you can take the control and you can start the 3D, 3D printing, whatever you want to talk about. Yeah.
Okay. So I hope you're getting my audio and the screen.
Yes, your audio is perfect and your screen is visible. I would just request you to be a little more louder.
Okay. Okay.
Yeah.
So this is the CURIN software, which is another open source software to just customize the generated STL files from the designed software, which is the Design Spark Mechanical, or any other 3D software. You can export your design into the STL format, and you just have to in order to convert these STL design into the G codes, you just have to import right here in this workspace, and you can customize in the basic setting and advanced settings. I'll go through briefly with this with the basic settings first. But before that, I just want to tell that how we can customize a machine that is 3D printer in this software. to the bed size, how we can customize the environment bed size in this software. So this is the very basic thing. Let me start with the set up the machine in this software. You can see here is the all the settings are available in this left side of the software, where you can see the file option. You can also load the model file from the desktop, and you can directly give the command to the 3D printer in order to print it, or you can directly click on the convert to the G code into the external device, which is could be your USB or the SD card. So these are the basic settings you can find right here. But in order to get this environment, you just have to set up the machine first. In order to set the machine, you can see right here the third option, which is the machine. Here's the I have already added the two machines that we have, which is first one is the Praman 3D printer and the Shaperjet 3D printer. And let me show you when I'm switching to the Shaperjet 3D printer, you see right here in the environment section, the size of the build volume or the bed volume is changed. Will be changed by this way. Now you can see the bed volume is changed because this printer volume I have defined, which is the 150 by 150 and in height it is 180 So I'm just going to repeat that machine specification of this machine as a new by adding a new machine. You can see I'm clicking on the add new machine by using a left click of the mouse button. You can see, let me share. Once I have clicked on the add new machine, you can see this window will pop up. So in this menu, you can see here is the add new machine wizard. In this, I just write down here is the next button. I just click on it. Once I have clicked, you can see there is a predefined 3D printer which has been just comes up, and you can see there is an other option. If your printer you cannot find right here, you can click on the other option. Once you have clicked on the other option, you have to press the next button. Once you clicked on the next button, you can see there are the machine information that comes with your 3D printer. So in our case, it is custom. I just want to customize that because that my printer I just want to customize according to my requirement. So I just don't want to get into this the predefined setting, because this printer has the external source bed and the other so many parameters that I just want to define it by a customize. And the customize is the best way to add your machine into the software. So once I clicked on the custom, I'll press the next button. So in the very first, see the label, it is a machine name. I'm just, entering right here is a test. So you can see the second option is the width of the machine bed. It's not the width of, the machine. I mean, it's the width of your bed, printable bed, in which, in what volume it is, print in the X direction. So in our case, it is a 450 because it is a dual extruded printer. So it takes the 50 in minus. I mean to say the overall the bed volume in X direction is 500 but it is able to print in 450 due to dual extruder. So in Y direction, I do have a 500 complete volume in and also in the Z direction it is again in 500 So this is, the dimension in X, Y, or Z of the printer that we are available, and the which is the, last but not the least option. It asks for the nozzle size. In order to print using a PLA filament, you need a nozzle. A specific size of nozzle you need to define in this software. So this printer comes with the variety of nozzle, but we have installed a 0.4 mm nozzle in this printer. So once you are done with the nozzle size, you can see here is a heated bed option, which I'm not clicking right here, because in my printer, in Praman printer, the heated bed is the external heating of the bed is heated by external source, external heating source. So I'm just not clicking right here. I'm just done with these 5 settings, and I'm just clicking on the finish button.
Just a moment. I want to ask a question on behalf of audience, because these are the certain things which these are the kind of doubts I'm sure participants will be having. So when you say this dimension, so this is your total build volume. That is a maximum size of the item you can print. 45 centimeter into 50 centimeter into 50. This is a maximum, right?
Yes, yes, sir.
Yes, and next is that all these specifications are listed on the printer's website. Whatever printer we are having, we can actually go to their website and see the specification, and accordingly we can customize it. Am I correct?
Yes, yes, sir. Yes. Okay. Or we can have the user menu with the 3D printer. We can verify it from there.
Okay, fine.
Okay, now I'm clicking on the finish button once we are done with this. Just click right here. So you can see here is a machine which is the test machine. I hope you are seeing the video. So in this machine, I'm again going to the machine setting, because I'm seeing right here there is it is a dual extruder printer. So I'm just getting here is a one parameter for the first extruder only. So in order to add another extruder in this machine, I just going to the machine setting right here in the machine option. Once I have clicked, you can see the pop-up window will comes up, and these are the I can also customize Praman 3D printer right here, shape budget, and that we have already add the latest machine, which is the test. So in this case, my extruder count, you can see here right below the dimensions of the build volume, you can see the extruder count. I'm just going to click on the 2, because it consists of the 2 extruders. Once you are done with this, you just have to click on the OK button. Now the left side of the window is refreshed. Now you can see here is the filament option. Now for the first extruder, that it asks for the diameter, what kind of diameter you are going to insert in this nozzle of the filament. So here is now you can see the second diameter of the filament comes appear. So this way we can add the machine and customize the machines in this software, and you can also observe that we can also add the multiple machines in this software. Once you are done with the machine settings, you just have to customize the basic setting according to your STL format. Let's start with by inserting a model into this workspace. You can see here is the load option right above the environment section.
I just want to interrupt you here. See, I'm sure most of these people are new to 3D printer. So I think it is better you explain these terms. What is the meaning of bed? What is the meaning of dual extruder? what is the meaning of extruder itself, what is the flow rate. I think it's important you mention briefly
Yes,
about
I just want to explain with by inserting a model, so
Sure,
it gives a better
sure,
idea
sure,
to
sure,
when I'm converting this layers.
sure,
So
sure,
yeah.
fine.
So I'm just loading a new material, your SQL file, which we have, we designed in previously session, which is the fence stand design. Once go to the SQL file, you just have to select it and open it, and it appears in this environment. So in this environment, you can see there is a black, arrows right here, which represents the coordinate system, or the position of the extruder, home position of the extruder. So when I'm going to start the printer or off the printer, my extruder will position right this coordinate system. So once you have inserted the design, in order to print it, you can see here, with this setting, you can see this much of time it would take in order to print with this kind of resolution. So I'm just going to shift into the Praman printer right here. First, you can see yes. Okay. So in basic setting, at very first, you can see here is the quality, in quality section, it is a first option, which is layer height. The layer height is normally, multiple value of the, you can multiple value of the, you can either you can define the resolution of your printing process for printing your object. If you want to print in the higher resolution, the printing will get slow, and printing gets slow, and it would take double time. I have just 0.1 pressed right here. You can see the time would be double in this case. Previously it was 0.2. It would roughly take 15 hours to 20 hours. So if I'm going into the layer mode, I'll later explain this. I just want to show this. The layer height is the height, the diameter of the filament coming out from the nozzle. That diameter is, when it's placed on the 3D printer bed, it becomes the layer height. So I hope you can understand this. The 0.1, the layer height means that the material coming out from the nozzle is in 0.1 mm diameter. So if I'm, increasing that diameter, which is pretty fine for the, print in order to print the all STL, designs or the objects in 0.2 cases, and also we can, extend it to 0.5 to, get the better accuracy. But the accuracy, mostly increased when the resolution would be refined, or decreased 0.1 to 0.2. So I just prefer always 0.2 mm layer height to better strength, in order to get a better strength, or the best resolution, or printing time would be perfect in this layer height. So after this, you can see there is a shell thickness. So in shell thickness, I'll show you what is the shell thickness. Right here in the graphic window, you can see. Let it complete the percentage. Yeah, now it is completed totally. So you can see the red sides of the of the object are are defined as a shell thickness. So right here, I just, put the 0.8. Why I, defined the 0.8? Why not 0.6? Why not 0.7? So the shell thickness is, the multiple value of the nozzle size. So if the diameter of the nozzle is 0.4, you can able to print the shell thickness with 0.8 or either in 1.2, which is the maximum shell thickness for the object. Either you can add 1.6. So if you mistakenly enter the 0.7, it shows you yellow. Or when you are moving your mouse into this software, you can see the section yellow section comes up here, and it shows the currently selected shell thickness is not a multiple of the nozzle size. So the shell thickness should be your multiple value of the nozzle size. For this case, I prefer 0.8, and it gives the perfect strength to the objects. If you want to add more thickness or want a more strength into the object, you can increase it to the 1.2. But make sure it should be the multiple value of your nozzle size. So if we're done with this, I'm moving to forward with the fill. Fill is fill is used to define or define the the fill defined with the yellow color in the in the object, which is visible right in the environment. So in this case, I'm just coming to direct fill density first. Let me show you. The yellow color represents the fill density. Right here, it is only the 20% fill density. They like we have created the walls of the object, which let me bring down that layer. Now you can see the fill density right here. So so the 20% the fill density you can come up here. If I increase the fill density more for the object, you can fill any like 21, 25, sorry, 25. It take a time to refresh the window, and there's some loading, visualization loading. It takes some certain time to represent the fill density. Wait for it. So I'm just add few things. The visualization depends upon your system configuration. It varies to visualize varies the time to visualize the object fill density. So you can see once I have clicked on the 20%, you see the density has been increased. Now I'm just going to change it into the let us say the 50%. It's again going to refresh. So if you are increasing the fill density, you can see the time would automatically increase because the more material going to be added by the 3D printer, and it would take a time to print it. And also the consumption would increase of the material that you are used to using that you are going to use to print it. Basically, we are using a PLA filament, which is a polylactic acid. Now the fill density is refreshed. You can see it getting a more denser by increasing the value, and you can check by just dragging this bar, and the number represents the layer number from 1 to 502. So in this particular case, with the 0.2 layer height, it would completed in 502 layers, approximately 500 layers. So the bed in that direction, it will going down into the 502 layers. So we are particularly right now in 340 layers at the 340 layers. So you can see the fill density is continuously same at all the layers which we are defined right here. So I'm coming to this, bottom or the top thickness of the, object, which is I have just defined to get the better thickness from the both side, even at the bottom or at the top side of the object. So I'm in this object, you can see there is, top side, you can see the top side is totally filled. So whatever the mm you are going to define right here, which is totally override the fill density. So I'm just filled right here 1.2 mm. So the 1.2 mm from the object will be totally filled by the 3D printer. So you can see, how much layers is filled by the 3D printer. Approximately right here, yes. The total 5 or 7 layers is totally filled by the 3D printer for this object. And for the bottom thickness, I'm just moving it to the lower level. See. You can see the very first layer, which overrides the fill density due to I have just defined the 1.2 mm thickness should be solid from all the sides of the object. So first layer, second layer, third layer, fifth layer, and then so on. You can see when I'm moving to this side, you can see this side, it not showing right here because it moves to the further layers, so it doesn't showing any visualization for the previous layers that has been that is going to be printed by the 3D printer. So in this case, you can see all the boundaries of the object, because there is no any solid part in between the in this that we in this pocket or the shell. If I'm moving further, I'm just going to show you. You can see here is the blue lines in this object, which clearly defines the position of the extruder, like how it is going to going from here to here, and how it is going to fill this density. So the line represents the the traces of the extruder represented by the blue lines. So once we defined all these settings, you can also the third parameter, which is the speed and the temperature. You also need to control the printer speed, printing temperature, which is the crucial part in order to print the PLA object. So the printing speed can vary up to 50 mm. We can define the printing speed from 35 to 50 mm, which is pretty fine in order to get the maximum resolution or the quality. If you are increasing the speed, the quality gets worse. You can see some of the objects get printed roughly from outside or the inside. It visible from the walls of the printed object. So I'll show you in the video. If you are if you are very expert, you can play with the printing speed, and you can also play with the printing temperature. So the printing temperature depends upon the filament that you are going to be used in order to print the object. So for the typical PLA filament, which is commonly used in order to print all the objects for the rapid prototyping. PLA filament is a very affordable, which is also non-toxic material, and it generates the less fumes than the ABS material. So if I'm comparing to the ABS material would take around to melt at 280 degrees Celsius, around 270 to 280 degrees Celsius, but the PLA filament melt at the 210 degrees Celsius, 200 to 210 degrees Celsius, and generates less fumes than the ABS material. So you can also find the printing temperature on the material that comes that we are buy or comes with the 3D printer, which is clearly mentioned on the box of the filament, the temperature printing operatable temperature for the filament. So once you are verified with that, you have to define the temperature for the printing, define the temperature for the filament right here in this section. Also, if you are going to print with the second nozzle, you also define the temperature for the second extruder as well. For right now, I'm not going to print with the second extruder, so I'm just going to put right here as 0. Once whatever the value you are going to change right here, it would again refresh the whole window. Okay, so further there is a support system. If some of the material is overhanged in the air, or you can see if I'm going to if I'm just going to rotate this object, you can also rotate this object from this sections. If I'm going to rotate this object like this way, you can see the sum of the material that is overhanged. In order to support this material which is the overhang, you can define the support system for this object, but which is not necessary for this case. So I'm not going to show this right here. I'll cover this all the support system and dual extrusion in the next session. So once you are done with the with the speed and the temperature, you just have to define the diameter of the filament. So the diameter of the filament is also comes with the filament specifications. You can also see on the print filament box. For our case, the nozzle, the diameter for the filament is 1.75 for the first extruder, and similar for the second extruder. But right now I'm not using this second extruder, so I'm putting right here as 0. And the flow of the filament through the extruder should be 100%. So make sure you are filling right here 100%. And the nozzle size, obviously, if you want to change the nozzle, you can also define the nozzle size right here. So this way we can define the basic setting in this software for the in order to print this object. So once you are done with all the setting of the object, you just have to click on the save toolpath option. It comes up here as a window, and you can see the toolpath file save as tab in the G code. So you just have to select the pen drive or the SD card right here, and you can save it, or you can save directly into the directory. Once you have selected the directory, I selected the D, and I just press the save button. So you can access the G code in the D drive. Once you are going to insert the USB, you can copy right here from to the USB, and USB or the SD card. That depends on your feasibility. And you just need to insert that SD card into the 3D printer in order to print it. So this is the Cura software where we can customize our STL objects, and you can see how we can convert it into the G code by just simply adding the few more settings according to our requirement. So sir, Sagar sir.
Chandra sir, I suggest
Yep.
you can quickly show the video
Okay.
of the 3D printing, without adding anything, so that people can relate what they have just listened. They should be able to relate it to actual 3D printing. We can just play the video. That's it.
So okay, sir. So right here, I have just clicked video. I prepared a video shot for the upcoming design, which is the nut and bolt.
No, I
Let
don't think
me,
so. That is a good idea. I don't think so. That is a good idea. You should show the video of this particular thing only, which we showed
Okay,
yesterday also. You can show this only
okay,
so that people can
okay,
relate.
okay. So let me, open.
Don't show your current design. First, let
Okay,
that excitement will go away now if you show the
yeah.
current one.
Okay, sir. Let me shift to the screen.
We can see your screen. I think you can play.
Yes, you are seeing my screen. I hope you are. Yeah. So these are the settings that I have just placed a screenshot in this video. See.
All right. So while you are watching the video, I would say a couple of things. First of all, I will share the link of this particular software with all of you. It's a free software. Sir, you can play the video and leave it. Yeah. So it's a free software. It's available, freely. So I can share the link with you. You can try 3D printing settings with on your own, and we will be very happy to print your 3D design. So let us say over the period of next 1 month or 2 months, you design something and you want us to print. We can print it for you and we can ship it to you. We can make a design. We can courier it. We will charge definitely, but only the operating cost. Whatever is the operating cost of our 3D printer and the material, that we will charge and we will send it to you. So whatever you want to get it 3D printing, I think it's a good opportunity. And I'm sure this brief session on 3D printing you must have found very good and useful, because you don't get so much of insight into 3D printing part in most of the places. So that way I think Chanpit sir has done a really good job.
So here you are just seeing, I have reduced the speed, and once the material is properly stick to the printer bed, I have increased the speed from 80 to 100% to just ensure that the object is perfectly in getting in shape by the 3D printer. So this is almost 15 to 17% of the object is completed. So this is it is almost around 20 to 25%. I'll show you. I'm just you can see and verify it from the control panel window, which is coming see. From here you can see it is the 23% of the process has been completed, and the first extruder temperature, the second extruder, heated bed, and the fan speed. And you can also customize the option which is not required at this time. The advanced options you can also find in the option setting, which is typically required at the very first stage, that used to reduce the printing speed, or the fan speed, or the extruder temperature. If the material is not getting in perfectly shape, you can also change the temperature right from the control panel of the 3D printer. You don't need to customize the printing temperature from this software.
Fine. So you're saying you can control it with this machine also, the temperature
Yes,
and
yes,
everything,
yes,
right? Yeah.
yes.
See, I think one thing is important that I have noticed that let us say you want to get something 3D printed and you go to external vendor. So if you don't know about all the intricacies of 3D printing, about the density and all those things, there are high chances that you can get cheated, because if that vendor can reduce the fill density, then the cost will come down for him and he can charge you more and all those things. Can it happen, Chandra sir?
Yes, it happens sometimes, sir.
It happens. So,
Yes. If we know the volume in what kind of the volume it would take, in order to print that object, we can just understand how much time it would take. If we have the STL file with us, so we can
yeah.
open it into the CURIN software, which is also open source. So where we can identify how much time it would take. We can verify it with the vendors. So if he's
Yes, yes.
mentioning the same
So I think
time,
that way this has been very useful. Understanding the basics of this 3D printing and all those things. Yeah. So if you have any questions, you can ask. Maybe I can take a couple of questions from you about 3D printing. If you have any questions, you can ask. Anybody? You can actually write in the chat box. I can unmute you. You can ask your question, because I have not seen many sessions on 3D printing. So I think that way, it has been very unique. So if anybody from the participant has any question about 3D printing part, I can wait for a couple of minutes and then.
Yes, sir, we can wait for couple.
So I'm not getting any queries in the chat box. So I think we can move ahead and go to the today's design. And do we have any questions from the previous 2 days? Sorry, from the participants. Do we have any questions from first 2 days? Anybody? Okay. I hope you're trying the designs. If not, you can see, like we had mentioned in our announcement also. So over the next 1 month also, we'll be happy to support you. So we understand that after the session, it may not be very feasible for you to try and get your queries and all those things. So we will be happy to support you after that as well. So I get one question. Sir, can we convert the design to animation through this software? Can we do animation through this software? Sir? Your voice is not coming, sir. Sir, I lost your audio. I cannot listen. Okay, Chandra sir is getting the audio back. Meanwhile, anybody else any question, you can type in the chat box.
Sir, you're getting my audio right now?
Yeah, we are getting. Can you answer this question?
Yes. I just want to confirm that which software you are talking about for Cura, or
yeah, I think they're talking about Cura only. Yes, the Cura only. Yeah.
So in Cura we cannot convert any design to the animation. So this particular software is just used to convert the STL file into the G code in order to print it into the 3D printer machine.
Fine. I think we can go ahead with the today's design.
So let's start with the today's design. It is a nut bolt. And we usually, found the nut bolt in various applications, in mechanical application as well, in the electronics application as well, in order to, fasten the equipment with the, with the another equipment. So, like for example, we have a one plate and we have another plate. In order to, join these together, these two plates, we need a fastener. So these fasteners comes as a nut and bolt. So, in nut and bolts, there is a threading around the shaft, or, in the bolt case, there is a threading around the shaft, and it is so, these components are just used to, fasten the object. So at very, first, in order to design, I'm just going to the file, new, and click on the design. So once I have clicked on the design, you can see in the structure menu, you get a design. To click, to rename this, part, you just have to click it and go into the property menu. You just have to define the name, which is the bolt. So you can see the nut and the bolt is a separate component. So first we are going to design a bolt, then a nut. Okay, so in this particular case, I'm going to design a bolt first. So I renamed it as a bolt and press the enter button. Once I press the enter button, you can see that it will be renamed as a bolt, and you can see the environment comes, the sketch environment comes up here, and I have, in order to sketch in the plain view, I just click on the plain view in order to get a maximum accuracy. Once I have clicked on the plain view, you can see I have I need a sketch in this particular plane. I hope you might understand, what kind of the shape of the, bolt is. So for right now in this, session, we are using the hex bolt, which is also known as hexagonal. So in order to draw the hexagonal shape in this environment, you go into the sketch. You can see here is the polygon option or the polygon command. You need to select that command. Once you have selected that, you just have to, go into the sketch feature. So where you can see the coordinate system, which is XYZ, and I'm just clicking right at the center of the coordinate system, which is the 0, 0. Once I have clicked the left click button, the parameters of the hexagonal shape comes appear. Which there are the 3 parameters you can see. First one is the diameter of the circle, which changes to the size of the polygon. So for this particular case, I just fill the 20 mm diameter for this case by just entering the value from the keyboard. And once you are done with the filling the diameter, you just have to press the tab button to define the angle. If that angle is perfect for you, so leave it as it is, and you can also to move further, you can also press the tab button again to define the number of sides you want in this polygon. So in this particular case, we need the 6 sides, or you can also define the number of sides. If you want a octagon, you can also define the 8 sides. Once fill the dimensions, the value for the sides, you press the enter button, you can see the sides will be changed. You can see the sides will be changed. So in this case, we need a 6 sides only. So I just press the 6, and you can see the 6 sides appear. So I'm just going to freeze again the diameter. So once you are done with all parameters of the hexagon or the polygon command, you can see the hexagon shape comes appear. And once the hexagon shape comes appear, you just have to click on the pull command in order to convert it into the 3D mode. So once you are in the 3D mode, you can see all lines are converted into the surfaces, and you can click on the home view to get a proper view. Once you are in the home view, you just click on the surface of the defined sketch and convert it into the 3D by just clicking a left mouse button. You can see the dimension will appear, and in order to freeze it, I'll just define it as a 10 mm right here. So this way you can see the head of the bolt has been built in the environment. So the next step would be the shaft of the threaded part of the hexagon bolt. So in order to draw that part, you just have to select the appropriate face for the proper face for the hexagon head. So in order to select that, you just need to go into the select button. Once you are into the select mode, you just have to select the plane of the solid. Once you are selected, it converted into the yellow color. And once it is selected, you just have to click on the sketch command. Once it's selected, the grids are available, and in order to get a maximum accuracy over this plane, you just have to click on the plane view. So once it comes appear perpendicular to the screen, you just have to draw the circle right here, because the threading is only defined on the on the circular part of the circular part of the of the bolt. So the circle, the center for the circle would be at the same point from where we just started the hexagon. So the diameter for this cylindrical surface would be the 10 mm. So once it is defined, you just need to exit from the sketch mode by just clicking on the 3D mode or either on the pull command. So once you can see it is converted okay. So you can see the another surfaces that comes appear. So in order to convert it into the 3D, you just need to select the pull command and move it into the positive direction to get a cylindrical shape where we are going to draw the threading. So the height for this cylindrical shape would be let us say it would be 50 mm. So you can see the raw shape of the bolt has been built by this way. Once you get this shape, so the only two things are left in this design, which is the threading and the chamfering of the head bolt. So first we are going to draw the a profile of the threading into the particular cylindrical shape. So in order to draw the threading to this cylindrical
ask
shape,
this question to the participants once, how to do the threading. Let us see what answers we get.
Sure.
Yeah,
sure,
can we get the answers on how to do threading in this bolt? See, so far it has been very simple design. We have taken one hexagon and when rectangular, and we just extrude it. So nothing new, whatever we have learned so far in first 2 days. So anybody who wants to give any answer on how we will do the threading on this bolt or this structure? I hope you understand what the threading is. I mean, it's so Chandra, can you show the photograph of the nut and bolt which you made, final one, so that
Yes,
people can
sure,
answer
sir.
this question? Because
Let me open the So I'm going to share the screen of the nut bolt right now.
yeah.
Here it is. Yeah.
Yeah.
So
this is
the
one which we 3D printed one, right?
Yes.
Yeah. So how he has done this threading? Can anybody answer this question? Threading on the bolt.
So this is the threading. You can see right here. So this is the threading on the cylindrical shaft, which is also known as the external threading.
Anybody want to try? We can unmute you if you want to answer this question. Anybody? No one? All right, I think we can go ahead. We are not getting any answers.
Yeah.
Yeah.
So
please, officer, you can move ahead, I think.
yeah. So in order to draw the threading into the particular shape, you just have to select the plane first. So you can find it into the insert window where you can see the plane option is available. In order to generate it, you just have to select it and click on the axis, or you can generate the plane on any face of the object like this way. Just you have to move your mouse onto the plane, and the plane will come appear. But in order to freeze it, you just have to click the left mouse button. So in this case particularly, I just need a plane at the axis of the bolt. So I'm going to select the axis and click the left mouse button. Once I have clicked the left mouse button, you can see the plane appears, and I'm going to disable this plane command by pressing a escape button. So this way you can see, when I'm moving my cursor to the plane, it converted into the sky blue color and the generated plane. So I'm going to select in order to draw a sketch on this particular plane. I'm going to select it and going into the sketch mode by selecting a sketch mode command, and you can see the sketch mode is turned on, and to get a maximum accuracy, I'm clicked on a plane view. So once it is we are in the sketch mode, we just need to draw the profile of the threading. So that the profile is revolve around the axis. I'll come to come later on this, but before that we need a profile which we are going to revolve around the axis in order to impression the threading on this cylindrical component. So in order to draw the profile, I'm just going to off the snap to grid, because it delivers the required movement of the line. So the profile should be in this case, the profile I'm going to define for the 1 mm in length. Now the profiles varies. If you have gone through the visualization of the board, you can see the different kind of profiles are available for the boards. So in this particular case, we are just generating the V threads on this board. So So in order to get the impression over the cylindrical surface, I'm going to draw the V shape right here. So this way, you can see the V shape has been created, and I'm just going to disable the command by pressing a escape button, and I'm going into the select mode to just customize it a little bit. Yeah. So you can see here the profile has been generated. The V profile for the threading is generated, and I'm just going to revolve this profile around the cylindrical face. So in order to do this, you need to exit from the sketch mode by clicking on the 3D mode. Once you are in the 3D mode, you can see the profile that we have generated or the build in the sketch mode is converted into the surfaces, and once you are going to select this and zooming in, you can see it is selected right here, but you are not able to select directly directly right from here, because it is inside the cylindrical surface. So in order to select this surface, you just have to go into the structure section and select right from here. So once it is selected, you just need to go into the pull command. Once you are in the pull command, you can see the additional options comes appear, or in this additional options you can see the revolve command is right here.
Mr. Can you just go a little slow? You are going a little fast, I think. Can you go one step back where you are selecting this surface on the structure?
Okay. Okay.
Till here it is okay. After this step.
Okay. Okay. So you can see we are moving into the 3D mode. So in order to select the surface, so you can select right from the structure menu by selecting this. Okay, by selecting this by clicking a left click of the mouse button. But I was just saying you are not able to select this surface right from here. If I'm zooming in, you cannot select right here from because the face of the surface is inside of the solid or the cylindrical surface of the board. So in order to select the entire surface of this profile, you just go into the structure menu and select this surface. So once you have selected this, you see it turned as an orange color, and the profile is got selected. So once it is selected, you just need to revolve this profile around this axis. So once you are going to revolving this profile around this axis, the impression would be created over the cylindrical surface. So I hope it is understandable that whatever the profile is going to be, whatever the profile we are generating on the on this plane is impressioned on this cylindrical surface. So in order to
actually just a moment, one person has written in the chat box, please bit slow. I think this is a new thing and little bit intricate, so people are finding it little difficult to understand. Maybe you can go a little slow on this. I suggest you repeat the last step once again from going from 2D to 3D, and somehow there is a problem in your voice also. Your voice is cracking in between. Sometimes it is not audible. Is my voice also like that? Because can you hear me clearly?
Yes, sometimes I think it might be the connection issue.
Sometimes okay. So then you can be a little more louder and little more slow, because this I think this particular element is quite important and people are not following.
Okay.
Yeah.
Okay, I just want to confirm that from where, from
I think
where
from
I should
2D,
start. Okay.
from 2D it was okay where you made that shape. After that, when you're coming to 3D and you're selecting it, I think from there you can start again.
So, this is
Till
the,
here it is okay. Yeah.
So, in order to, define the threading, you just need, profile, thread profile. So once you are done with the thread profile, you just, need to go into the 3D mode. So once you are in the 3D mode, you can see the profile that we are generated in the sketch mode is converted into the surfaces. So to select this particular surface, you just need to go into the structure bar right below the the menu system. So here you can see the surface that you have been drawn in the sketch mode. So I'm going to select this surface because you are not able to select the surface right from here. So that is why, because this surface is generated inside the cylindrical surface. So you are not able to select any surfaces or the object which is already inside the another object. So in order to select this surface, you just have to click right here. So it turned as turned into the orange color. Once it is got selected and you verified it is selected, you just have to revolve this profile around this axis to create the impression on the cylindrical surface. So in order to impression it, I'm just going into the pull command. In pull command, you can see a very first command which is the revolve command. So the revolve command is just basically to revolve any generated profiles around the axis, around the plane. So in this particular case, we are just revolving this profile around the axis only. So I'm going to select this command by clicking a left mouse button. Once it is selected, you just have to click on the axis. Right, like this way, I'm just want to revolve the profile, generated profile around this axis. So I'm going to select this axis. Once it is selected, you can see it is turned into the blue color. So once it is turned into the blue color, you can see the advanced options are available right below the property section. You can see here is the general setting, and further you can see there is the revolve option. In order to customize the revolve of the particular profile. So in order to customize it, I'm going to select the revolve helix command. In helix, you can see the line around the cylindrical surface has been created, which is helix. In order to generate that helix, you just need these three parameters. First one is the height. What would be the height of the helix? So in this case, if you want the entire threading on the entire shaft of the or the bar of the bolt, you can fill the entire dimension, which is 50 mm in this case. So once you have filled the height of the helix, you have to press the tab button. Please make sure that you are pressing the tab button, not the enter button. Press the tab button once you have filled the height. You can see there is a line comes appear as a helix around the cylindrical surface. I hope this is understandable to all, how we can customize the revolve command by using a revolve helix, and for that you need three parameters in order to generate a helix around the cylindrical surface. So there is a second parameter, which is the pitch. So pitch is defined, one revolution of the helix. So one revolution of the helix, in this case, the height between the one revolution would be 1.2 mm, because we define the height of the profile is 1 mm. So the pitch would be 1.2, which is the standardization for the bolt threading. So once you have filled the pitch, I kept the taper angle 0. You can see once I have filled the pitch, you can see the helix profile has been changed. You can see, I hope it is visible to all clearly. I'm zooming in. So you can see the helix has been, updated from 5 mm to 1.2 mm pitch. So once, it is, defined, I press the enter button. Let me repeat it again. See, 50 mm, 1.2, and I hope there might be some issue. So, once, created into the surface, I'm just, going to again into the revolve and select the axis and click on the revolve and define the 50 mm and define the pitch, which is the 1.2 in this case, and press the enter button. Why it is not 50? Okay. I'm just let me check. There is some issue in the in the profile. I'm going to redefine the profile which has been generated in the sketch. Let me go into the into the profile mode again. So there might be some issue in the profile. I'm going to delete this particular profile. I'm just going to generating right above of the above of the cylindrical surface. See. Yeah. So this time I'm going into the negative direction by just dragging the helix into the downward side. You can see the helix is going to be generated over the surface. Or I'm going to freeze it. I'm pressing the value -50 and press the enter button. So you can see the threading will appear, and it is generated threading on the bolt. The previously there might be some issues in the profile that has been generated in the sketch mode. So I have generated the profile again over the cylindrical surface, and you can see the threading has been generated over the cylindrical profile. So this way
can you repeat the last step again a little slowly maybe? after doing everything, when you are just making the thread on it by dragging it, can you repeat that step?
Okay.
And
Okay.
how you're
So,
doing it? You're pressing the button and holding it and dragging. How you're doing?
Yes, I'm just, once, the parameters comes up here, you just need to define the first, 1.2 mm. So in order to, play with the height, you just have to click on the helix by clicking the left mouse button. I hope it is clear. So once you have clicked the left mouse button on the helix, you just need to drag in the downward direction. You see the height comes appear as a negative in the checkbox. In the checkbox, you just, if you want to freeze that dimension, you just have to press the spacebar button. Once it is, freezed, I release the helix. My mice got, released, and I fill the required dimension, which is in the negative direction, which is -50. Once it is filled, you just have to press the enter button. Sorry. I'm doing it again. Once profile selected, revolve. See, we were here, right? -50, or we can directly fill the -50. See, the threading has been generated. If you are not comfortable with the dragging the helix into the downward direction, you can directly fill the -50. The helix will be generated over the cylindrical surface. So I hope this is understandable to all the participants, that how we can generate the threading over the cylindrical surface in order to generate the threading. Once it is generated, the last part is left in order to create a chamfering over the head bolt. In order to create that, I'm going to disable the pull command first by selecting the select command. Once it is selected, you see I'm
John sir, we lost your audio. Hello?
Hello, my voice is audible?
Now it is audible. We lost it actually.
Okay. So in order to generate the chamfering over the head, you just need the there is a question from the participants. Let me
Yeah, that
see
I will take
first.
later. You can complete this part.
The surface created for thread
Sir,
is
you
now
can finish this part. We can take the question later.
While we were getting error while keeping that at bottom, does it matter? No, ma'am. This doesn't matter. I think it was an issue with the profile. Just I have created the profile upside to avoid the error that comes from the bottom side. So you can play with the either you can define the profile on the right side of the cylindrical body even. So in this case, I have just defined the profile of the thread at the upside of the cylindrical surface. So I hope this is clear to you, ma'am. So now we are moving further to generate the chamfering over the bolt head. So in order to do this, we just need another component in the structure menu. Once you are going to click right click on the structure section, you can see a bolt and onto the when you are going to right click on the you can see the following options are available, but here we just want to enter a new component in this particular structure. So I'm just clicking over the new component. You can see the new component is added. I'm renaming it as a chamfering. or also you can name it as a chamfer. So you can see the chamfering has been inserted by by using a new component, but the chamfering is not just created, but we just need to create by generating a sketch over this in this component. So you just need to select this component first and go into the sketch mode. You can see the plane appear, but in this particular case, I just need the plane right at the plane side. Here. Yes. So नहीं मैंने इसको हटा दिया. So I hope my voice is audible, perfectly right now. So you see, we have generated another plane right here. Once the new component has been inserted, we are going to design into the new component. So in order to define the chamfering into this particular solid, we just need to create a sketch into the new component. So in order to create a new component, in order to create a new sketch into the new component, you just need to go into the sketch mode. Once you are into the sketch mode, you just have to click on the plane view to get a maximum accuracy. So right here, I'm just creating another hexagon shape to this particular solid, like this way. I'm just going to select the polygon. Once I have selected the polygon, I'm just clicking right at the center where the previously polygon has been drawn with the same diameter, which is 20 mm. So once it is drawn, I click on the enter. You can see the hexagon has been built over the sketch, and I'm going to convert it into the 3D. I'm just in order to do this, I'm just going to the pull command. Once you are in the pull command, you can see there is a surface which is a sub part of the chamfering component. So here you can you can see when I'm moving my mouse over this plane, you can see in the structure the surface is highlighted as a yellow color. So which makes me sure that the perfect the perfect surface is going to be selected, or I'm going to convert this surface into the 3D. So in order to convert this 3D, like we have previously done, we are dragging it into this direction and fill the dimension about 10 mm, which was the previously defined for the head. So in order to define the chamfering, we just replicate the bolt head in a new component. So once it is converted into the solid, you can see it appears as a solid. If I'm selecting this component, only the head of the replicated head of the bolt has been selected. Otherwise, if I'm going to select this component, you can see the whole component of the bolt is selected. So in order to work on the chamfering, I'm going to select this again, and I'm just going to chamfer the head of the of this solid. So in order to chamfering, Previously we have used the dress up feature in order to provide the round corners around the sharp edges. So here to the sharp edges we just want to provide the chamfering, which is the inclined line between uh, uh, between this edge. So in order to do this, I'm just going to select this edge, and by pressing a control button, I'm going to select the another edge, and same this edge, this edge, this edge, this edge. So we are selecting the folders in the window. We just have to press the control button and clicking over the files to select those. So the same method is applied here in order to select the all edges of the component. So once the all edges has been selected, you can see in the dress up features, you can see the second command, which is the chamfer. So once I have selected this command, you can see there's the arrow comes appear over the edges. And I'm just clicking a left mouse button over the arrow and dragging it into the towards the solid, and you can see there is a 0.9 mm dimension, and so on, continue to moving, keep on changing while I'm moving into this direction, or reducing when I'm moving to this direction, backward direction. So in order to freeze this, I'm just pressing a space bar in order to freeze this. So the chamfering, dimension will appear. So right here, I'm just, filling 1.5, which would be fine for this case. Once I have, pressed that fill that 1.5 mm and press the enter button, you can see the chamfering has been applied to this particular solid. So once the chamfering has been defined to this particular solid, uh, we 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 just need to use the combine command again in the intersection options. So in order to use this command, I'm clicking on the home screen to get a full preview and spinning it around this way, and a little bit right downside, and so you can see the combine option is just previously in previous session the ma'am has been told that we are if we want to combine two components to make it a one, we can also use the combine, but in this case we are using the uh, uh, combine command to split two components into different parts. So in order to click on to split the components into different parts, I'm just going to click on the combine command. You can see there is a cutter option. So once the cutter option is selected, you just have to select the another solid. So which is the previously drawn the you can find it on the bolt section, which is sub part of the bolt. So you can see once I have clicked on the solid, you can see the following components has been generated. In order to see the perfectly created the chamfer over this board, you just need to disable the required feature. Let me see. Let me repeat this command once again. You can see, the chamfering that has been provided to this circle, to the to this hexagon. We are going to select the combine command. So here you can see, I'm going to select, the software asking to select the, first component. I'm going to select this bolt first. So what part I'm just going to remove, which is the solid. So this part is, you can see the bolt has been created with the multiple solids. So from right this section, I'm just going to disable those parts are not required. So you can see so this way we can generate the chamfering, and split other components into the different parts. So this is the, the final shape of the bolt. So this way we can generate the chamfering over the surface and split it into the various components. So now on, we are done with the the providing the chamfering and the threading over the board. So now I'm moving to the nut section, nut part of this board. I hope this is clear to all how we can generate
just a moment,
the threading and provide the chamfering over the surface.
Just a moment. Hello, can you hear me? Chanpit, are you getting my audio? Chanpit, are you getting my audio?
Hello. नहीं सर आपको ऑडियो नहीं आ रहा.
Are you getting my audio, Chanpit?
Yes, right now I'm getting the audio, sir.
Okay, so let me take a few questions if people have. Does anybody have any question on this part? I think it was a bit tricky. So do we have any question, or shall we move ahead? Nobody is responding to my call. Do we have any question? Chanpit sir, how long will it take you to do the bolt part? Sorry, the nut part. Is it too time consuming?
No, sir, it's not a time consuming.
So I think you repeat the chamfering part once for the audience. I'm sure some people have missed the step because there were a lot of steps involved, and there were a lot of selection.
Okay.
And why actually we are doing the chamfering? Why cannot we do the simple round shape or something like that? That also you explain.
Okay, sir.
Yeah, but make it little quick, huh?
Sure, sir.
Yeah.
So here you can see we are in the previous view, which is the bolt. So in this case, I'm just entering a new component in the structure menu in order to provide the perfect chamfering to the bolt head. So once it is selected, you can see it asks to rename. I'm providing a rename it as a chamfer. So once it is renamed, I click the enter, and I'm going to select this component in order to generate profile of the chamfering in this particular component. So in order to draw this. Once I have selected, I need to go into the sketch mode. Once I am in the sketch mode, I have to select the appropriate plane. So the base plane would be fine for this case. Once I have selected this, you can, no, this is not the base. So I'm going to select again the sketch mode. You can see this is the base. So I'm going to select this plane. Once the plane is selected, you can revolve it, you can spin it this way. Once, it is in the perfect view, you just go into the, plane view. You can see uh, the plane is perpendicular to the screen, and I'm just going to draw the another component right over this plane in order to provide the chamfering to the bolt. So in order to do this, I'm just going to provide the chamfering with by using the circle command. So I'm just selected the circle and select the previously the center of the coordinate, and so this is the second way of the chamfering by selecting the circle command, and or basically it is a provides the perfect shape to the bolt head. And you can see, once the corner of the hexagon bolt head is, joined this corner, it appears as a green color. You can see right here, and shows the diameter of that circle. Once it is, coincide at the edges, and just press the enter button. Once, the diameter has been freezed, I'm going into the pull command in order to convert it into the 3D mode. So you can see there is another surface which has been converted in the component in the chamfer component. So I'm going to convert this surface into the 3D by using the pull command. You can see I'm moving it into the positive direction. The height for this typical component would be the 10 mm. So you can see the component covers the bolt head. Once it is covered, you just go into the select mode, in order to release the pull command. So once it is cover the bolt head, just apply the combine command to these two components. In order to apply the combine command to this component, I'm just going to select the combine command, and going to select the first component, which is the which is the sub part of the bolt. So I'm going to select this solid, and once it is selected, I'm going to select the cutter. So to split, split into the sub parts. So, so it again asking for to select the another solid, from which solid I'm going to split into the different parts. So I'm going to select the second solid. You can see the various but before that, I will just left the providing a chamfering to this particular cylindrical surface. So I'm here filling the 10 mm. So see, once the component is covered the another component, which is the cover the bolt head. So I'm providing the chamfering around this cylindrical surface by just clicking over the edge.
If you want to provide the chamfering right down below the bolt head, you can also provide, but you need to select the this edge also by pressing a control button and press the left mouse button. You can see the both selected, the both edges are selected and highlighted as a yellow color. Once they are selected, you just need to select the chamfer command. Once the chamfer command is selected, you can see there is an arrow comes appear. In order to draw the chamfer, you just need to drag it into the downward direction. You can see the dimension comes appear. For this case, I'm just keeping it, 1.5 and press the enter button. So you can see there is, chamfering provided to the solid, which is, some part of the chamfer component. So in order to, split into the multiple parts, I'm just clicking over the combine command and, you know, in combine command, once you are selected, you just need to select the first solid from where you know, split another component. So the first command is, by default selected. I'm just to make sure that it is selected. I'm click the left mouse button again over the command, and I'm just going to select the another component again, and you can see there is a multiple solids has been created into the structure section. From here, I'm just going to disable some solids which is not required in this particular case. Like this is not required, so this is required the active component. This part is not required. This is not required. This is not required. The all sharp edges are not required in this particular case. So I'm just going to, disable these all sharp edges. And in last, I'm just going to disable the cylindrical surface. You can see the perfect, chamfering has been provided around the bolt head. So, and same at the bottom. So you can see this bolt is right now is not as an active component. So I'm just going to, right click on the bolt and make it as an active component. So once, it is, comes in alive as an active component, it, appears as a green color. So this way we can provide a chamfering and threading to the board. So I hope this is understandable. I hope is clear to all, and I know it is very tough for you, or a bit tricky, that how we can what component we have to disable from right here. But make sure, I'm just want to clear right here. Please disable only those components. Those are the sharp edges, particularly in the bolt head. So it varies upon the another component which solid you want or do not want. So if I'm talking about you are not required this part. So the head, you do not need the head in this particular case. You can also disable this. So once it is disabled, you can can save it into the in the raw file and convert it into the STL. The only this component will be printed. So if you are enabling this component and you are converting it into the STL format, the whole bolt will be printed over the 3D printer machine. So please be specific into the into the selection mode, what component you are going to select in order to get a perfect shape in the printing process. So we are clear with this.
Chanpi sir,
Ji, sir.
I think it is, you're able to hear me?
Yes, sir.
Yeah, so this is fine. I think you have explained it quite well. And I agree with you, it is quite tricky how to do the champering. And I think the second portion that you did with the circular thing made it a little more clearer, because now
Yes.
it is a little more visible, the champering, and people can relate to the actual board. See, what I suggest is we can leave the nut part as an exercise and let people do it. And on the August 10th, when we have a discussion session, we can again come back to it. And then you can show the, if people are not, if people are finding any problem, we can, you can again show that. Is it fine? Because now I don't think so we have time. We only have like 10 minutes, and I don't think so it will be, correct to do it in the 10 minutes, because it might require some more time. You agree with me?
Yes, sir. I'm agree, sir. So some of the part might be missed due to the less time. So
yeah, so that's why
only two commands are used. In the nut. First one is a threading, and the second one is a champering.
Yeah. So what we can do is, what we can do is, we can show them a video now of the nut and bolt which you have made. Okay, and then we can leave nut as an exercise, right?
Sure, sir.
Sure. And then I have one question in the chat box. Somebody is saying correct chamfer. I don't know what he means, so I'm just unmuting that person, Padmakar, and maybe we can ask him what he wants to ask. Yeah. Can you ask your question, Padmakar? Are you there? I'm asking you to unmute. You can please unmute yourself and ask your question, because in the chat box, whatever you have written, it's not clear to me at least. Padmakar, are you there? No.
I hope it might be some issues with
yeah. So maybe you can show the video and of the nut bolt, which you have 3D printed video and all, and then maybe we can conclude the session. And leave this again. I'm repeating, this nut is an exercise for you. If there are any, do we need to give any specification, Chanpreet, to them for nut?
What, sir?
So for designing the nut, do we need to give any specification?
No. There is no specification required. They can, use the standardization. Okay. For in this particular case, we can, use an internal threading, and the dimensions for the hexagon would be basically we draw the head or the nut of the bolt, with the required nomenclatures, which is the D. Once we are defined the diameter of the
Hello.
Internal threading.
Hello.
So,
Shabbi sir, can you please hold just a moment? Yeah, please ask your question.
Please. Hello, I am Padmakar Chikri speaking. I have made comment that it is correct jumper. Hello.
Yes.
It's because last picture you have shown that is the hexagonal right up to the top surface. It is not the hexagon right up to the top surface. Here you will see that on top surface there is a circle.
Yes.
Okay, so basically you are saying that
that's why I made comment that this is more correct.
Okay,
And
we
second
get it.
The second thing actually this is the nut, and here you will find at the bottom there should be a flat surface. There should not be any chamfer.
Correct.
Yes.
Correct. We get it.
Yeah. Okay. Thank you, sir. Thank you very much.
Thank you. So, Chanpi sir, let them. I understand what you want to say, but let them design the nut as per their specification and however they want to do it. We will design it for this particular board in the discussion session, and then they can compare. So I think that is how we want to do it, right?
Yeah, sure, sir.
Yeah. So let us show the quick video and then we conclude the session. Can you please show the video?
Let me shift to the screen.
Yeah. it's a 4-minute video. Huh? You can actually skip
Yes,
some of the parts. Yeah, maybe.
actually, in this, I'm showing right here, you can see the filament, to before installing the filament into the extruder, you can see there is some disturbance right at the end of the filament. In order to remove this, you need to cut this way. Once cut it into the appropriate shape, you can see the perfect shape of at the end is provided, and you just need to install into the first extruder. So this one is the first extruder of the 3D printer, and this one is the second extruder, and we are using the first extruder in this particular case, and we are printing the nut into the red filament in the red color using a PLA filament. And right now I'm just to verify the extrude options right right from the control panel of the 3D printer, to verify the filament is perfectly installed or not. So in order to to check that, I'm just select the first extruder and define the increment, which is the 10 mm, and select the low speed, and perform the select the in option, and select the twice to 20 mm of filament is extruded from the nozzle. You just verify that the material is perfectly installed, and the if some of the material which is which was previously installed, which let us say it is a black color, so the black or red got mixed if I start at very initial without removing the without removing the black filament from the nozzle. So once I have clicked on the in option, you can see there is a filament which is coming out from the first nozzle. You can see right here the 20 mm of filament has been extruded by the nozzle, and we just need to remove this. Once it is removed, you can see the following commands right here. In order to this one is the particular for the extruded temperature, which is I have defined 200. You can also turn off the extruder to or increase the temperature of the bed. So in this particular command, move command, you can move the extruder into the different coordinates, and also move it into the home position in XYZ. And from right here, I'm just going to select the required G code, which is the nut, and click it on confirm button. Once the temperature meets the defined temperature, it starts printing. So here you can see with the very first layer of the nut, so from here you can see the fill density, which is filled in the nut body. So once it is completed, I am going to select the another component of the same design, which is the bolt converted into the G code. So once it is selected, you can see it is start processing over the control panel, and the first layer is laid down over the 3D printer bed. So, in this case, it is printing the bolt head first and then the shaft along with the threading. So you can see here, the same field density is applied to this particular body, which is 20% field density. So this is the final picture of the bolt. So here is some little demonstration to just show that we can, use these components this way, both components. Sir, over to you, Sagar sir.
Okay, thank you, Chanpreet. I think it was really fascinating. I'm really sorry for some of the hiccups that we encountered. I really want to apologize to the participants. Due to some unreliable internet connection, we lost audio and all those things. In spite of all the best of efforts, sometimes technology do fail us. But I hope you understood most of the things. You will go back and try to do this designing of the nut portion with the internal threading and all those things, and we'll come back to this in the discussion session on August 10th, where we'll again design this nut, and you can then compare your design technique with our design technique. That way it will be a good exercise for you. Meanwhile, I once again repeat, if you have any queries, you can write to us and even call Mr. Chanpreet. So I hope you found the session useful. You learned something new. If you have any feedback, you can again write to us. We don't have any time today to take feedback here. So thank you very much. We'll see you again tomorrow, and we'll do another interesting design tomorrow. Thanks a lot.